Hello, I would like to talk about the TPM support in GRUB2 for legacy boot mode. I am Michał Żygowski and I work at 3M Dev as a firmware engineer. I am closely focused on firmware for x86 architecture, mainly core boot, some security solutions on the low level, and advanced hardware features. And here's my social media information for contact. And yeah, what the problem is exactly. In the current world, most of the firmware implementations rely on the UEFI specification, and the boot process integrity works mostly for only UEFI-aware systems. But when we look around, for example, for open source implementations, there are many natively non-UEFI implementations like core boot, liberboot, orboot, U-boot, cBIOS, Linux boot, skiboot, and so on. Currently, they barely have any integration for maintaining the security chain from the firmware up to the operating system. Although there are some existing solutions like Petit Boot, which bases on the Linux kernel and the measured kexec mechanism, and the trusted GRUB2, which is based on GRUB 2.02, with additional TPM stack implementation and lock key management and unsealing the secrets, etc., etc. And it utilizes the legacy BIOS interface for the TPM 1.2. There are also some other efforts like hardened BSD call for participation to unify and collaborate on development of the security features. Who should care about this implementation, for example, for GRUB2? For sure, it should be Chromebooks users who want to, for example, repurpose the device, users of the previously mentioned firmware and bootloader stacks, most distributions which are supporting non-UEFI legacy boot mode, or the cloud providers which use, for example, QEMU with cBIOS, like the hypervisors like Xen and Proxmox. What exactly is needed here? So basically, firmware starts with SRTM, which is a chain of measurements starting from the core root of trust for measurement, which is the first measurement done by the firmware right after the RESA vector. And for example, the current implementations that support it are, for example, core boot, and they're open, which do the measure, extend, and execute. Then we are going into the some bootloader, for example, cBIOS and GRUB. And on one hand, cBIOS already has support for both TPM families and does the measurements of the basic components like master boot record, etc. And then we have the target bootloader, which loads the Linux kernel, for example, like GRUB, which currently does not have any integration of TPM for non-UEFI aware systems. And the last level is the Linux, which also lacks TPM2 support mostly, although there are the TPM2 tools. However, there is no early TPM code in the Linux 2 to measure, for example, the compressed part of the kernel. Yeah, I have talked a little bit about the status, but to clarify, Coreboot already has the measure, extend, execute mechanism beginning from February last year, if I remember correctly, with the vboot implementation. But currently not every payload can extend the trust chain. For now, cBIOS does it because it has the TPM support for both families. It measures the Ember master boot record code and exposes the interrupts for TPM 1.2 defined in the TPM specification. And yeah, it is the same interface, but I will explain it later. And yeah, and GRUB2 doesn't even support at all TPM except the UEFI interface. Okay, so Trusted GRUB currently relies on the API of the interrupt API 1A from the TCG/PC client specific implementation specification for conventional BIOS, which describes how the interface to TPM should look like for legacy BIOS implementations, not to UEFI ones. And yeah, this specification only covers the TPM 1.2 for now. However, CBIOS have implemented it to be transparent for both TPMs. It has a quite well abstracted interface that it covers the TPM family and just provides the unified API, for example, for extending, etc., etc. However, it introduces some small inconveniences, which I will also explain for a moment. And yeah, so Trusted GRUB utilizes the installed interface for the TPM, for example, by CBIOS, and does the measurement of the GRUB itself, and for example, for the commands used in the shell of the kernel of the command line. It's also capable to unseal some secrets to unseal Lux partitions. Yes, and there was one topic which extensively discussed the TPM2 support for the Trusted GRUB. However, the creator or maintainer of this project said that he won't do that because he doesn't have enough time to do that. So CBIOS, like I said, exposes those APIs, but for now it doesn't do SHA-256 implementation, so it only calculates SHA-1 hashes and extended in TPM 1.2. For TPM 2.0, the hash is padded with zeros and then extended into SHA-256 banks on TPM 2. So this is another issue to be resolved. And as I mentioned earlier, the TPM driver in CBIOS is abstracted in such a way that it hides the TPM version from the bootloader perspective, because it uses unified interrupts as defined in the specification. But the specification, on the other hand, says that the TCG version, the TCG protocol version, should be returned in certain registers, architecture registers, and those are hard-coded. So it kind of tells that this API is compliant with some old interface and not necessarily complies to TPM2 interface. There's also another register which returns a signature, some kind of magic string like TCPA, which is also defined in this specification and has to be returned in this API. But TCPA refers to the ACPA table which corresponds to TPM 1.2. For TPM 2.0, this table is called TPM2. So this also introduces some confusion whether we are interfacing TPM 1.2 or 2.0. So currently this is not distinguishable, and I believe it should be able to, for the bootloader to be able to distinguish the TPM to differentiate the boot flow, because for sure we have to, in some situations we have to handle the boot flow differently for TPM2. And yeah, now what has been done in Trusted GRUB to achieve this security feature? The master boot record assembly called the boot.s has been rewritten to measure the disk boot image, which is responsible for measuring, which is responsible for loading the rest of the GRUB and measuring the rest of the GRUB. and just the ember was rewritten to measure this disk boot image. Then the disk boot image on the other side was rewritten to measure all of the rest of the GRUB which is loaded. Yeah, and then in the kernel of the GRUB, there was implemented the measurement of the modules which are loaded already from the hard disk. And of course, a TPM driver was required for the kernel of the GRUB in order to measure the modules, the kernel, and the GRUB config with the command line options. And also, as an additional security feature, Trusted GRUB implements also the measurement of the shell commands that are executed through the GRUB shell. And also, there are integrations of the disk encryption, decryption, unsealing TPM secret for lags, etc. So like I mentioned earlier, the CBIOS problems to be solved are distinguish the TPM 1.2 and 2.0 in the interrupt API, and possibly add a SHA-258 implementation for TPM 2.6. I'm sorry, 256 for the TPM 2 extra banks. And this is the list of the modified files. The diff was made based on the GRUB 2.02 tag, which Trusted GRUB is supposed to base on. And yeah, it looks mostly like there are some additions to some crypto and LUKS implementations, the TPM interface, hooks to the Linux loader, to the multi-boot, and as I mentioned, the disk boot and boot.s has been modified in order to measure the subsequent chunks that are loaded. But due to the restrictions of master boot record that it has to hold, for example, the partition layout, etc., it was necessary to remove floppy disk support, for example. Yeah, and there's, yeah, who cares? Floppy disk is not used nowadays. Yeah, QM. Yeah, and some header files also, which I think was unavailable. So in total, 32 files change, 3,400 of lines insertions, and 360 deletions almost. Yes, and the open questions that are still unanswered, and we hope to get an answer, as if the adoption of interrupt 1A doesn't make any sense in terms of, for example, expanding kexec based solutions or not. In the sense whether we should go for a kexec, or rather is it feasible to implement it in GRUB2? Another question is why GRUB2 did not adopt the TPM implementation still. TPM or there was no implementation of CSM or open source BIOS implementation that would expose this API. And another question is whether can GRUB2 rely on a TPM. For example, I don't know, if we have a TPM present, if we should enforce some measure boot mode.
Oh, okay,
And yeah, some summary, quick summary of conclusions. Without that any legacy compatibility support module exists with these interrupts. And yeah, both solutions would require some implementation in the bootloader for cases where bootloader is encoded in firmware, for example, in core boot. Yeah, so this is it. Thank you.